Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 6 to 10 of the June 2019 Algebra 1 New York Regents exam. In this presentation, we're going to be doing a detailed coverage of each problem. We're going to go through this process step by step. If you like something quicker, go ahead and visit our website at mathgotserved.com under New York Regents exam, where you can go through the solutions to these problems at your own pace. Don't forget to subscribe to this channel so you can get notification of updates to the remainder of this review series. Alright, let's take a look at question number 6. In question 6, we're being assessed on how to identify if a function is exponential or linear given a table. Okay, so question 6 reads, the function f is shown in the table below. So this is f of x and this is x right here. And question, which type of function best models the given data? Is it exponential growth, exponential decay, linear function with positive rate of change, or linear function with negative rate of change? Okay, so if we're given a table, how do we know if it's one of the following? Let's go ahead and indicate exactly how to identify each of these types of functions given a table. Okay, so the first one, an exponential growth function. In that case, the growth process will be as follows. It will involve multiplying by a constant. So you multiply by a constant. That's the common factor, okay, or the growth factor. You multiply by a constant. Let's call that constant r, and that constant is always going to be greater than 1. Okay, so if you're multiplying by a constant, the same number over again, and it's that number is greater than 1, it will generate an exponential growth function. How about decay? It's similar, but a slight difference. In this case, you're going to multiply again. You're going to multiply by the same number over and over again. Multiply by a constant. This is a decay factor in this case. But that r factor will meet the following condition. That r, or that constant or decay factor, is always going to be between 0 and 1. For example, if you have an r value of 1/2, you're going to have an exponential decay function. If you keep multiplying by 1/2 over and over and over again, you have an exponential decay function. How about linear function with positive rate of change? If you have a linear function, you're going to be adding, is an additive process. Okay, you're going to be adding a positive number for a positive rate of change. So you're going to add a constant. Let's call that constant m, and that number that you're going to be adding over and over again will be greater than 0. Okay, if you add the same positive number over and over again, you end up with a linear function with positive rate of change. How about linear function with a negative rate of change? In this case, you're going to add a constant again, but guess what? The constant is going to be negative. Okay, so let's call that constant m. Is going to be negative. Alright, think about a negative slope of a line. That's the deal here. So if you add in a negative number repeatedly, is equivalent to subtracting that number over and over again. Alrighty. Now another thing that can help us with this problem is to note the behavior of the function. Okay, what do I mean by behavior? So in the exponential scenario, if you have growth, what does that tell you is going to be happening with the function? If you have a growth scenario, that basically tells you that the function is going to be increasing. Alright, the behavior is it's going to be going up. How about positive rate of change? Positive rate of change tells you the behavior also. This is a scenario where the function will be increasing also. Alrighty. Now, what about decay and negative rate of change? Decay basically indicates that the function is going to be decreasing. That's what decay does, right? The amount is going to be reducing. So decay means it's going to be decreasing. And a negative rate of change basically means you have a negative slope. What do you know about lines with negative slope? They're decreasing, okay? So just by considering the behavior alone, you should be able to eliminate options. What am I talking about? Now take a look at f of x. As x increases, what is happening with f of x? 1, 3, 9, 27. It's increasing. Okay? So since f of x is an increasing function, it tells us that we can eliminate option 2 and 4 since those two functions exhibit a decreasing behavior. Alright, now the growth factor or rate of change can tell us how if it's linear or exponential. Alrighty, so let's take a look at it. Now, let's act like we don't know what the answer is. Alright, so we're going to look at this. So if we go from 1 to 3, it's two possible things that are happening here. Either you add 2, okay, 1 plus 2 is 3, or you multiply by 3. Alright, now if what we're adding is the same constantly, then it's going to be a linear function with positive rate of change. If it's not, then it cannot be a linear function. If what we're multiplying is the same, is a constant, then it's going to automatically be an exponential growth function. Alright, so let's see. If you go from 9 to 7, from 3 to 9, that's an addition of what? Addition of 6. Oh dear. We're not adding a constant. This is variable, so it cannot be a linear function with positive rate of change. So the answer is automatically option 1. Okay? Alright, but let's go ahead and show the whole process. So from 3 to 9 is equivalent to multiplying by 3. And then from 9 to 7, to go from 9 to 7, you add 18, right? You see how this is changing? So we see it's not linear. Or from 9 to 3, multiply by 3. Ladies and gentlemen, I hope you clearly see what the answer is. What's happening here is that we're multiplying by a constant that is greater than 1. Okay? Alright, so let's write that down. So what's the deal here? When you multiply by a constant that is greater than 1, what kind of function is it? Greater than 1. So you constantly multiply by that constant greater than 1. It tells you that it is an exponential growth function. It's an exponential growth function. So the answer to question number 6 is option 1. Okay? Alright, so how would you rate the level of complexity of this problem? 1 meaning extremely easy, 10 means extremely difficult. How easy was it for you to solve this problem? Give your rating. 1 easy, 10 means extremely difficult in the comment section below, and tell us why you think the level of difficulty corresponds to the number that you assigned to it. Alright, let's take a look at question 7. In question 7, we're going to be assessed on how to carry out operations and simplification of radicals into rationals. Question 7 reads, which results in a rational number? The square root of 2 times the square root of 18, 5 times the square root of 5, square root of 2 plus the square root of 2, 3 root 2 plus 2 root 3. So we need to remember what rational numbers are. In order to do well on the Regents exam, you need to know what your rational numbers are. Okay? So all these involve radicals. So let's focus on how to identify a rational when it's presented in radical form. So recall, you need to remember that rational numbers do not have radicals. Do not have radicals in their simplest form. In their simplified form. Okay, so if you simplify a radical completely and there are no radicals present, then that radical is a rational. For example, the square root of 9. Okay, this is a radical. If you simplify the square root of 9, you get 3. Since the radical is gone, that means that this is a rational number. Alrighty. Uh, for example, let's consider another example. Root 7, for instance, in its simplest form, root 7 is just root 7. So this is irrational. Alright, so hopefully you see the difference. Okay, so we're gonna simplify all these alternatives that we have. As soon as we hit one that does not have a radical in its simplified state, then we know that that's the correct answer. Question one, option one, root 2 times root 18. So the formula for this one, let's just put some formulas here for simplifying radicals. You can always multiply radicals. There are no constraints there. So let's say you have root x times root y. All you do here is you multiply the radicands, all right, root xy. Applying that formula here, root 2 times root 18 is simply going to be the square root of 36. And we know that this is a perfect square. Okay, so think about it. One number multiplied by itself is 36. It's 6, right? So this is rational. Why? Because the square root is gone in its simplest form. Bam. Ladies and gentlemen, the answer to question 7 is option 1. Alrighty? Alright, let's take a look at the others. Number 2. What is 5 multiplied by the square root of 5? 5 multiplied by the square root of 5 is simply 5 root 5. And this is irrational because you still have a square root in the simplified state. Question number 3. What is the square root of 2 plus the square root of 2? Now let's go back to another formula in simplifying radicals. If you are adding two radicals with identical radicands, it is possible to combine them. All you do is you add the coefficients. Alrighty, so like in this case, let's say you have root x plus root x. There's an imaginary 1 here in front, that's a coefficient if it's not specified, and there is if it's not imaginary, it's invisible. Alright, because it's a multiplicative identity, so that's why it's invisible there. Alright, when you add these two together, guess what it becomes? This becomes 2 root x, okay? So do not add the radicands when you're adding radicals. You add the coefficients, alrighty? So root 2 plus root 2, following this pattern here, we know that we have the coefficients. The invisible coefficients we know are 1, so let's reveal their identities. When you add these two, what happens? When you combine these two, first of all, are they combinable? The answer is yes. Why? Because the radicands are identical, but that's not what you're going to add. Okay? The radicands help you to determine if you can combine them or not. And then after you determine that it can be combined, you just combine the coefficients. Alright, so we're going to add 1 and 1. 1 plus 1 is 2, so this is 2 root 2. Root 2 cannot be simplified. This has a radical in its simplified form. Hence, this is an irrational number. Okay, so we see why these are not the answers. Option 4. What is 3 root 2 plus 2 root 3? Now, let's look at this closely. Can we combine these two? The answer is no. Why not? Because the radicands are different. Remember, the radicands must be the same in order for you to combine them. Very important. So in this particular case, the radicands are different. Can we combine? Absolutely not. So the answer is simply what we started with, 3 root 2 plus 2 root 3. Since this number has radicals in its simplified form, it is irrational, hence it is not the answer that we desire. Alright, so we can clearly see that the answer to question number 7 is option number 1. Alright, now a question for you to think about. In option 3, we added we added two irrational numbers, okay? We added two irrational numbers and we ended up with an irrational number. So the question is that always the case? Whenever you add two irrational numbers, do you always end up with an irrational number? Let us know what your answer is. Just post your answer in the comment section below, and we'd like to see what it is. Alright, let's take a look at question 8. In question 8, we're being assessed on how to generate or write polynomial functions from graphs using roots. Problem 8 reads, a polynomial function is graphed below. So we have the graph of a polynomial function right here, okay? The question is, which function could represent this graph? So we have 4 options. So now the question is, what is the connection? How can we connect this graph to the polynomial function or related polynomial equation? The connection is as follows. Let's note the following point. So one thing you want to note is that the x-intercepts, okay? The x-intercepts of the graph of a polynomial. What's the significance of the x-intercepts? Oh wait, they are the roots, also known as the solution, roots or solutions, or you can call them zeros too. Roots or solutions to the polynomial equation, to the polynomial function, okay? Alright, so what does this mean? Well, that means that we just have to follow the following steps. We'll extract what the x-intercepts, roots or solutions are from this graph. We're going to set them equal to 0, multiply the resulting expressions by each other, and then we'll get what the polynomial function is. Okay? Alright, so let's do it. First one, we need to find the roots. What are the roots of this polynomial function? The roots are the x-intercepts, right? Let's see. So we have, this is the x-axis. So wherever the graph cuts the x-axis is the x-intercept. So we have an intercept here, an intercept here, and an intercept here. So this value is -2. This one is 1. And this guy right here is 2. So we have 3 roots or solutions or x-intercepts to this polynomial function. Alrighty, let's go ahead and write that down. So we have the roots are x equals -2, x equals 1, and x equals 2. Alright, next step, we're going to set the roots to 0. Set to 0. We are unsolving this equation, kind of, sort of. Alright, so how do we set them? How do we make them equal to 0? So I need this -2 on the left side. What do I combine with -2 so it becomes 0? Combine the opposite, right? The opposite of -2 is +2. So you add 2 to both sides of this equation. And what does that result? You end up with x plus 2, x plus 2 equals 0. Over here, I need this one to become 0. So what do you do to +1 to make it 0? You combine it with its opposite. The opposite of +1 is -1. So you subtract 1 from both sides. X minus 1 is 0. And then lastly here, what you do, you subtract. You do the opposite of +2, which is subtract 2 from both sides. Alright? Okay. So you do that, and then you end up with x minus 2 equals 0. Alright, so they've all been set to 0 now. Excellent. Now the next step is to multiply the left side, the resulting expressions on the left side. These are the factors, okay? So multiply the factors. So if we multiply the left side, this is the reversal of the zero product property, okay? So remember the zero product property, if you're working backwards, this is what you get. Okay, so set equal to 0. Now we're going to multiply. Now if you notice x plus 2 and x minus 2, there's something special about those two. Let's put them next to each other. So we have x plus 2 times x minus 2 or let's do this. If you look at the options that we have, the component with 1 comes first. So let's put that first. Okay, so it's similar to what we have. So let's put x minus 1 first, and then x plus 2 times x minus 2. So that takes us to the question, when you are multiplying factors, does order matter? Yes or no? I'd like you to put your answer in the comment section below. Let's see if it matters or not. If you say it does matter, explain why. If it doesn't matter, explain why. If you say you can multiply in any order, then what property of equality are you referring to, or provides you basis with doing that? The fact that we are reversing the order of factors being multiplied by each other here clearly shows that it's a legal process, but we want to know what you think. Okay, x plus 2 times x minus 2, that should help you remember a particular expansion of factorization formula. A plus b times a minus b is the factored form of a difference of squares. A square minus b square. So if you have x plus 2 times x minus 2, do you know what that's going to be? It's simply going to be x squared minus 4. Okay? So this is known as the difference of square formula. Now, let's assume you don't know this, okay? So we have to multiply these two because all the options involve some kind of x plus or minus 1 component and the product of the other two factors. So if you don't know this trick, it's okay. You just multiply it out. First, outer, inner, last. Bam. Just multiply it, right? Okay, so we'll bring down x minus 1. And if we multiply this out, we have x times x is x squared. X times minus 2 is minus 2x plus 2x plus 2 times minus 4 is minus 4 equals 0. And then we can simplify further. This would give us, what would that give us? It would give us x minus 1 times x squared. You notice that the middle terms can be combined. They're first degree terms here, like terms, but they're opposite, so they basically take each other out, right? And then we're left with x squared minus 4 equals 0. And we see where this plays a role, right? Alright, so this is the related polynomial equation. The function is f of x equals x minus 1 times x squared minus 4. The answer to problem 8 is option number 3. Alright? So this is the function that when graphed will generate this result right here. Okay? Another way you can do this problem is you just plug in these functions into the graphing calculator, and then you will see which one results in a graph that looks just like this. Alright, so let's take a look at how to do this using the graphing calculator. Of course, if you're doing it with a graphing calculator, you have to graph all 4 and see which one matches. We already know what the answer is, so I'll just show you how to graph the correct answer, and then you will see how it compares with the graph, okay? So f of x is your y. We're just going to enter the right side of the equation. So we have x minus 1 times quantity x squared, x raised to the second power minus 4. Hit enter, and then graph. Bam. So you see how graph number 3 matches perfectly with what we have on the left right here. Alright, so some of you might wonder, it's much easier or faster to use a calculator to determine if a function has a particular graph or not. So that takes us to the following question. If you can simply use a graphing calculator to establish what the look of a function is it necessary to be able to determine if a function has a particular graph algebraically or manually? Okay, so the question is, all this work we did right here to come up with the final answer, is that necessary with the availability of a calculator? Let us know what you think. Just post your answer in the comment section below. Okay. Alright, let's take a look at question number 9. In question 9, we've been assessed on how to make use of the properties of equality, okay? So we are going to be given two steps, and basically our task is to identify what property of equality was applied in the algebraic simplification process. Alrighty, so we have four options here. Before we get started with the problem, let's go ahead and refresh our memory as to what our properties of equality are as indicated here. So some of them apply to, a lot of them that we have here apply to both addition and multiplication. Okay, so first one, do you remember what your associative property of uh, multiplication and addition are? Well, it's as follows. For addition, if you have a plus b plus c is the same thing as, so you have these two associated together and you add first, is the same thing as a plus adding b and c together first. Okay? So however you associate or group the numbers that you're adding together, it doesn't really matter. You get the same thing. For multiplication, let's say you're multiplying AB and then multiplying the product by C is the same thing as multiplying BC first and multiplying the product by A. Okay, so this is known as the associative. Think about associative as grouping with parentheses. Commutative, think about commuting. Commute basically means you're moving, right? So if you have a plus b, for addition, it tells you that a plus b is the same thing as b plus a. So you notice how these two have their positions have moved. So a is not a second term, b is the first term. The order has been switched, but the sum remains the same. Okay? So commutative property, think about order. When you're adding or multiplying, so a times b, the order does not matter. Alrighty? So that's your commutative property. Now the distributive property, just think about distribution. If you have a, well, this one is a combination of addition and multiplication. So let me put it in the center. A times b plus c. What you do is you just distribute, right? A to b, a to c, and then that gives you ab plus ac. Last one, addition property of equality. If you have an equation statement, let's say a is equal to b, then what you can do is if you add the same number value to both sides, let's say you add c to both sides, guess what? The equality is preserved. So then a plus c is equal to b plus c. Bam. Alrighty, so let's see what's happening in the problem that Kate is working on. So Kate started with p squared plus 5 equals 8p minus 7. And then she ended up with p squared plus 12 equals 8p. What happened here? You notice that this negative 7 that was present here before is no longer present. So she kind of got rid of the negative 7 from the left side. So the question now is, what do we do to both sides of this equation so that this negative 7 is gone? To get rid of negative 7, we use the inverse operation. What is the inverse of minus 7? The inverse of minus 7 is you add 7. So what we're going to do is we're going to add 7 to both sides of the equation. Do you see what the answer is based on what we just did? What we did is we added a constant to both sides of the equation, and the resulting answer is going to be p squared plus 12 equals 8p, which is this right here, this equation. So we added a number to both sides of the equation, so we can clearly see that this has nothing to do with association. Commutative, no distribute, it's option number 4. That is the answer to this question. Alright, so if you take a look at all these 4 properties, which one do you think is easiest for you to remember? Which is the easiest property for you to remember? Go ahead and tell us your answer in the comment section below and tell us why that particular property is so easy for you to remember. Alright, let's take a look at question number 10. In question 10, we're going to be assessed on our ability to generate a compound inequality in a scenario presented in word form. So it's basically like a translation, right? We're translating from word form into algebraic form involving compound inequalities. Question 10 reads, David wanted to go to an amusement park ride. A sign posted at the entrance read, you must be greater than 42 inches tall and no more than 57 inches for this ride. Question, which inequality would model the height x required for this amusement park ride? Okay, alright, so we can see that x represents the height, so let's go ahead and declare our variables real quick and then get started with the problem. So let x be your age. Alright, so what we have is we have two inequalities here that we're going to be combining. It says you must be greater than 42 inches. That's the first condition. And no more than 57 inches. Okay, so you want to keep track of this word. Very important. And. So it's like a combined inequality. We'll talk about that in a second. Alright, so firstly, you have to be greater than 42 inches. So greater than 42 inches. Let's represent that on a number line. Okay, so we're gonna generate two number lines, the two graphs, and then condense them into one, which is going to be the final result. Okay, so let's say we have a number line like this, and this is 42 right here, 42, and let's call this 57. In your number line, when you go in the right direction, it's getting greater, yes, and then if you go to the left, you're getting less. That's how the number line is configured. Okay, so greater than 42, what does that mean? Can it be 42? No, it has to be bigger. Any number bigger than 42, okay? So we're going to put a open circle there to show that the value 42 is excluded, and we go to the right forever. So any number to the right of 42 or greater than 42 will satisfy the first condition. Okay? And then next it says, and and okay, so we're gonna combine this with another inequality, and no more than 57 inches, no more than 57. Okay, let's see here. If it's no more, that means it has to be 57 or less. That's what no more means, okay? So it could be 57 or less. So this is 57 right here, close circle. So anything that's 57 or smaller, so less is what direction? Less means you're going to the left. Now, one thing you want to note is that if you have an and inequality, you can always combine it to 1. Okay, so let's write that down. Something to note is that an and in a compound inequality in most cases, okay, sometimes you have no solution because the inequality makes no sense. But if it's an inequality that makes sense, if you have an and in a compound inequality, it can be combined. Okay, they can be combined. It can be combined into one. That's a general case. Sometimes it doesn't work, but in most cases you can do that. Okay, so to illustrate, let's say you have the following compound inequality. For example, you have a certain number y is greater than 2, and y is less than 10. Guess what? This compound inequality can be combined into one. Since y is greater than 2, that means 2 is less than y, and then y is less than 10. Bam. Okay? So you can always combine, in most cases, you can combine inequalities with an and situation. So graphically, we're going to combine these two together. When we combine these two together, let's see what is going to happen. So when we combine these two together, let's see, what are we going to have? We're going to have, on the left side here, 42 is excluded. So when we combine them together, this open circle is going to bore a hole in this one right here. So it's going to be open. And then everything in between all the way to 57. Is 57 going to be closed or open? Well, look at the point in the second inequality. The second inequality is closed. So that tells us that the resulting combination of the two is going to be closed also. Alright, so this is the resulting inequality right here. So how do we write this inequality? This inequality is 42 less than x, and x is less than or equal to 57. Okay, so the top one, this inequality is x is greater than 42. This inequality right here is x is less than or equal to 57. Now when you combine these two together, x is greater than 42 and x is less than or equal to 57. You end up with 42 is less than x and x is less than or equal to 57. So that is what our final answer is. The solution is the combined inequality statement. 42 is less than x and x is less than or equal to 57. Alrighty, the correct answer to question number 10 is option, where are you? Option number 1. Alright, so that's the correct answer right there. Alright, so if we take a look at this question, we combined two inequalities and we were able to graph it. Okay, we ended up with this nice little graph right here. So that takes us to the question, when you combine two inequalities, do you always end up with a region that you can graph? Question again is, when you combine two inequalities, do you always end up with a graphable region? Let us know what your answer is in the comment section below, the yes or no, and explain why you selected the answer that you. Thanks so much for taking the time to watch this presentation. As indicated earlier, we would like to know what you think. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very important to us. Don't forget to subscribe to our channel. We update our page with math videos almost every single day. So subscribe so you can get updates to the uploads that we've made. If you have any questions, comments, or special requests for presentations you'd like us to work on, just post it in the comment section below. A lot of support resources can be found on our website, mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.